Good afternoon. My name is Boelen. I'm founder of Seccomp, my own company, and I'm helping companies with auditing. And it's an extension to previous work. I created rkhunter. Can I see some hands with people who already used that before? Okay, a few. And Lynis? People, one? Okay. rkhunter is specifically for scanning malware on Linux and Unix systems, and Lynis is a more generic tool to scan the security defenses of your environment, and specifically focused on Linux and Unix systems. Today I'm talking a little bit about Docker, because it's a hot topic, and I'm seeing it being an extension to the Linux ecosystem in which more and more people are using it, but on the level of security, people simply skip that part. They see it being flexible, they see they can scale quickly, but sometimes they simply step back or take a few steps back regarding their security defenses. And well, my goal is to extend tools like Lynis and provide information about Docker and security in particular. So why I'm interested in Docker is to get an understanding in it, because I see it being equal to what VMs did for physical machines, and I think Docker and containers in general are the next step regarding that. And then I'm doing development, so it's a logical extension to that as well. And of course I'm using it myself to get better understanding, but also trying to use it within my environment and the environments I'm using it for my customers. Well, after a lot of research, I found a few disturbing issues, and well, one is there isn't much information about it, and if you find something, it may be already being outdated, so that's interesting as well, because it's still a new subject. Some information is very conflicting, so you see, well, some advice on one page, but it actually doesn't work anymore, so it's sometimes, because it's outdated, sometimes wrong understanding of the subject. And usually security is not really that important as it looks. So, an interesting one. My proposal is to fix a few things, and well, of course it's not something I'm doing alone. It's everyone being interested in the subject itself, being Docker or being security, or even better, the combination. So this is the main proposal, and it's a combination of building the right tools, doing documentation correctly, blogging about it, presentations like this, or also giving input to existing projects. Because if you look, for example, on GitHub, you see a lot of Docker-related snippets or container information, but it contains a lot of well, even vulnerable configurations. So actually those people who, well, who try to do their best to help others, they actually make it worse for them. So an interesting one as well. So the goal today is quickly well, to stabilize the big vessel and then secure the containers on top of it. We look quickly at the benefits of Docker itself, and then especially with regards to security, the risks involved with using Docker, defenses Docker has to provide already, and some best practices. The whole thing is about one thing only, and that's data. After all, well, unless you're using Docker just to play with it, usually you want to do something real with it, and that might be providing, for example, an Nginx container, which on its turn is sharing data with the rest of the internet. But in the end, it always comes back to data. In one or the other way, you want to show data or avoid showing the data. So it's about the data sharing, and it's about keeping some data confidential. Small warning, and that's Docker is going very fast, very, very fast. So I might be telling something right now, which is well, simply a lie, or not true anymore. So if you catch me on something, raise your hand, let me know, and we fix it. Some benefits, well, the clear ones already, which most of us know. It's flexibility, scalability, and better testing. As a developer, you can now run something, you should be able to pick it up and then run it in the same way as the production environment. And well, that's an interesting and clearly a primary benefit it has. Regarding security, one big benefit is that it provides segregation. So you can split up a big chunk into smaller things and then build defenses around it, ensuring that, well, less information is leaked out or your defenses become easier to control. And most security people consider it to be the holy grail. Segregation, splitting up things gives most of us the idea that we can better secure it. It's granular and similar. You can well, limit access, and also again then you have the opportunity to better understand it and to easier to defend yourself against any threat or any issue which comes from it. Information disclosure is often an issue which most people don't really see, but it's there, and well, by using containers we can actually keep things smaller and improve our defenses. Some risks, well, it's not specifically for Docker, but Docker has it as well. And that's well, the simply bugs, and well, if you follow GitHub and the Docker repository, you see well, a lot of changes being made, and usually that's because of, well, features, but especially a lot of bugs being solved. Security vulnerabilities. A year ago, Docker had some, well, not really that many security issues being discovered, but since the 1.3 and 4 releases, they really had to cover up a few things, and they got well, pretty hard smashed in the face regarding issues on that level. So they, well, they woke up and said, okay, security is not something we can skip anymore. We should really build it into the product because people are asking for it. Well, with all those quick developments, that means also a lot of updates to install. And then there's always the big question, well, with all those people contributing, well, how safe is it really? Are people not making the same mistakes which we have seen with the go-to-fail in macOS? It's easy to make a mistake, and especially, well, with many contributors. Then there's the knowledge gap. Well, not sure how many people here have an IT auditor around in their company. No one? Someone? Other people who do security checks for them, like pen testing or okay, not that much, but for those people it's really hard to keep up with this because it's not their main work, and it's just one of the many tools being available right now. Yeah, so that's a challenging one, but also for your colleagues it might be interesting, even for you and yourself. Staying up to date all the time is, well, pretty challenging. and I see it myself as well. I have to do research all the time to make sure that I'm not telling too much lies in my presentation. One of the biggest issues is still the isolation and the not being able to contain. So Docker is getting better in it, and you can put more defenses on your container to make sure that it does isolation. But at the same time, it's still not a full real container which keeps things in balance. For example, when using a container, it's still, if you are able to get root inside the container, you are also root in the host system itself. So that's a clear escape hole, which is a very serious issue. That's one of the last ones and big ones which needs to be resolved before being able to do full containment. And the final goal is that if you would be able to own a container, that you should be able to do nothing except what the application can do as well. But in the end, you should say, okay, throw the container away and the infection is away as well. It could be an infection or a malicious person. So some defenses Docker already built in, and that's also being caused by the earlier mentioned security issues they had. So they started going for HTTPS only. They added signatures to the downloads and related verification to ensure that what you're downloading is really that what you believe, or what you believe you're downloading is really what you're downloading. Container technology, and I think most of us already know, but it's around namespaces and C groups to isolate the Linux OS. And by splitting up functions within the operating system, you can effectively create a container. Without it, there's no container possible. One of the other things they use is Seccomp, secure computing mode, and capabilities, which is in short the root user split into many separate roles, and those added to the container. And then last but not least, frameworks. We will see more about that. So namespaces, they do isolation, and there are different namespaces, like for process IDs for the network itself. So you can say, okay, this container can only do some routing to that part, or maybe even being blackwalled so that it cannot do anything. And you have user namespaces, and that's one of the biggest issues regarding the root permission. So if you be root in the container, outside it, you have the same access. And that's depending on the user namespaces, and that's totally implemented. Then that gap is also closed. Then you have IPC for process communication, hostname and NIS and other related naming parts, and the mounting itself of volumes. Seccomp, the secure computing mode, there are two modes in that. I'm not sure if anyone already used it before, who heard from it in the past. Okay, who's using Chrome, Chrome browser? Oh, what else are you using then? If no one is almost never Firefox. Okay, that's okay as well. Well, Chrome is using it, for example, to build a sandbox. So it's not sandbox technology, but you can actually limit what kind of functions are allowed. And by using that properly, you can build your own sandbox. And as stated, it's isolation, not virtualization. So it's not a layered approach. It's really you limit access to the related process. It's especially interesting for developers. If you want an application and you say, okay, I want to limit the possible risks in what it can do, then you can use Seccomp mode 2 to achieve that like Chrome. And there's an example list of functions which are blocked by default, so you cannot, for example, load the kernel module, which well helps already a lot of countering against some attacks like loading a malicious module which bypasses other function calls. Control groups, it's well, like a scheduling agent, so it restricts well, what you can do. It's about resources, about priority, about accounting, so what has someone or what has some process done, so it's also interesting for well, billing purposes, maybe for big SaaS companies which want to know, okay, this is what user and what process has been used, and to bill according to that. And it's about control, so you can say, okay, this process has to be in sleep mode now, or this has to be started up again. Then you have capabilities, as said, the root user split into many different smaller roles and smaller functionality. There's a default list of allowed capabilities. You can add them with minus cap minus add and an equal one drop, or you can combine them together and say, okay, I want to drop first everything and then add a few, or you can say, no, I want to add everything and then deny the ones you consider being malicious. These are a few of the many capabilities. People are already aware of Linux capabilities, seen them in the past. No one? Yes. Oh, okay, sure. Capabilities is really some technique which is there for a long time already, but you never see it unless you, well, if you, for example, do the ping command, if you remove the setuid bit, then it won't work anymore. But if you add a capability to open a network socket, you can make it work again. So it's a nice trick to get rid of the setuid stuff and still being able to get it working. Then the frameworks, UpArm or SA Linux, people use that. Oh, that's more. People who directly shut it down when they see it on their system, SA Linux, for example. Desktop, okay. Well, it's interesting because of it being a stable framework, you can isolate as well. You can specifically say, okay, this process can access that or it cannot do that. So, as listed here as well, if you learn it now and you get familiar with it, you can also apply it to containers, and that's of course an interesting one to extend it. Because containers are small and easier to understand, then you can make your rule set small as well. While normally on a full system, you need to have one policy for everything and to make sure that that your system does what it should be doing. Regarding containers, if you make once that small snippet of things it should be allowed to do and deny everything else, then that knowledge can be really simply applied to other containers which have a similar role or similar piece of software in it. The audit subsystem, people using that? Okay, a few as well. See those two gentlemen using everything already. That's nice. Red Hat developed it, and it's mostly about setting a watch on files itself, or file handles, and on system calls. And it's very powerful if you want to know what process or what a process is doing, or which process actually changed the time, for example. If you see your time jumping off, then you can say, okay, what is the related system call? You put a watch on it, and you can quickly see, that's crazy shell script, or that's program is changing my timeline. And it could be everything. It could be setting the host name, or it could be creating a user, or whatever is interesting in your case. Then the audit subsystem is a powerful method for detecting that. It would be looking something like this. And for example, if you want to track your password files, and you put the watch on it and the related file, the permissions, and you can give it a key name so that you can group similar files, like the group file, the password file, the shadow file, so that you can quickly search for those events which are later logged on the system itself. Especially with System D now as well. System D and audit, the audit subsystem are working very well together. So if you have one local place on where your log data is, then the audit events are there as well. And if you properly use the keys, then you can find information back, or else it will be a challenge. Then some best practices. Well, first of all, the Docker host itself. If you really do some serious hardening and auditing, you start first of all at the level of the hardware, of course. But then next level would be the operating system. Security is defense in depth, so you have to really apply it on multiple levels. And you can use the frameworks as mentioned. And you can, of course, limit who has access to the Docker host itself. And well, it's common practice, but still access and permissions are still given away too early and too often. Make sure that your kernel is up to date, sometimes because of features, but sometimes also of well, nasty bugs discovered, which really affect your Docker installation as well. And important as well, the Docker installation on the host itself, it should be kept up to date because of the security issues, but also the features that you have. And what you see now is that Docker is really adding new features also regarding security almost every release, so that gives an idea how important they see it right now. Then the containers itself, well, UpArmor and SABinix apply. Capabilities, the preference is to drop first every capability available, and then add only the ones really needed. That's the ideal situation. Depends a little bit on the complexity of the software being executed within the Docker container. Similar using Seccomp, it depends a little bit if you can use it because of the origin Docker has with LXC and what they are using now, their own lib container part. So that means that Seccomp functionality is not always available anymore. I'm not sure if they will bring it back. And then you have also the IP tables filtering, which you can apply, of course, to make sure that some traffic is allowed. It's the network user space. You can already configure the routing, for example, and then put IP tables on top of it to limit also specific traffic patterns. A few new things are read-only containers, so that's Docker 1.5, read-only parameter, and that helps in adding a restriction to what a container can do on what particular volume. Then the logging, it was an issue before, and it happened that logging was stored in a container or not at all. And what you can do now is define a log driver to get the data actually outside the container itself, which is a better place to store it, and then send it to a central device or storage device or what you have in mind. And also a new one is the U limit, which is well, already available on your OS itself. You can actually move it also to your container from that level, which is helpful, for example, with file descriptors. You don't want one container being able to fill everything up and still conflicting with the other containers. So that's one part of the pieces in which it's not a real security escape, but at the same time you can cause a denial of service with it if you don't apply. Then another one is regarding Docker management itself, so the management of the containers, where possible encrypt your connections. And it's set with these two variables. I see more and more people actually using it, so it took some time, but it's getting better. Then common one, which is also getting better. People want to manage their containers, so they put SSH in it, and Docker saw that more and more people were doing it, so they built a better alternative, and with the exec command or the nsenter command, you can actually go into the container itself, and you don't need a daemon like SSH anymore. Well, the obvious ones, what you can make read-only, well, make that read-only, and it might be a mount point on your NAS device, or it may be a local piece of data. And as said, the read-only parameter applies here as well. Then the mappings, that's the user namespace. Well, that's the thing which is not finished yet. Some newer Linux kernels and versions have it already. And what is defined is if you are root on the host itself, then you have normally user ID 0. What you now can say is I want a root user for my container, but map it on a different user ID on the host system itself. So it can be user 10,000, and that would be equal to root in the container, but if you escape from it, you are still user 10,000 on the host itself. And of course, you don't give that user any special access on the host itself, which helps limiting and decreasing the risk involved with the attacks before. And when this is finished, then the user mapping part will be very helpful regarding the value what containers have to offer, because usually it's the escalation of user permissions which help penetrating the rest of the system as well. So then the trust part, still people download images from other people because they just want to play with it, but that's also a different or a riskful thing to do. It's Russian roulette. Sometimes people have the right intentions, but sometimes people simply build in backdoors as well. So where possible, don't use it. Then there are some tools. Well, Lynis is my own tool. Since January, I built a plugin which hooks into Lynis itself. You can use it to audit your Docker files. What I've seen by investigating a few hundred of Docker files on GitHub, there are many common mistakes people make, even use change mod 777 on files. Not sure why people do that, but okay. But also downloading external components with any verification, for example. And that's well, the Lynis is free available, and if you say, okay, Lynis audit Docker file and then provide the Docker file itself, it will see those kind of common mistakes and say, hey, you have this in it. Maybe it's on purpose, but maybe you want to fix it. Another interesting part is OpenSCAP. I'm not sure how familiar people are with OpenSCAP. One? OpenSCAP is the open version of SCAP, obviously. And SCAP is a protocol, and it's focused on automation of security content. Well, it still doesn't say that much, except that it's a set of rules, information, and scripts. And what it does is it helps you scanning your systems by providing XML files and also pieces of script to mitigate any issues found. So you can build a policy into an XML file and say, okay, I'm going to run this on this system, and any issues from that will be marked as as a finding. Or you can even say, oh no, I simply want to fix it. I will always want to ensure that some value is set to 1. OpenSCAP, well, it's very popular in the US, and that's because of the US departments, especially regarding the defense departments and those who fall under FISMA, the federal security guidelines. They have to comply with it, and OpenSCAP is helping that as well. And the last but important thing, Docker goes very, very fast, so if you're using it, make sure to keep up with the updates itself. Also the news. The blog itself, I must say they do that very well. They give a lot of information. And the news itself is an interesting part to follow as well, because it's nice to run Docker in an environment, but if you at the same time have a lot of runnable Docker images or containers, well, the risk might not be worth the flexibility. So it's a thing to look at. Then time for any questions, if there are any.
So if you turn off the SSH daemon in the Docker container, but you're hosting for someone else, how do you give them access?
Yeah, that's an interesting one. It depends if and why people need access to the container itself. So if you really need to do management on it, then you can also maybe, but it depends on your situation, of course, you can give them access to the host itself and do the management from there. If they have simply or need access to one container because there are many customers on the same host, yeah, they maybe don't want to do it. So I would say it depends on your situation, which is wise. But from the basic point of view, if you don't need it yourself, don't add it. And if you say, okay, my customer really needs that, that's a fair point, and then can still opt to add it. Yes. Okay. Any other? Okay. Then I'm done. Thanks for your time.